Alright. We are doing polar rectangular equation conversion. Alright, so yesterday we learned about polar and rectangular points and how to convert from one point to the other, right? An xy to an r theta. Today we're going to do actual equations. So let's remember what we learned yesterday just a little bit. Things that are going to come in handy today, like x squared plus y squared equals what? R squared. And tangent theta was what over what? Y'all remember? Y over x. Make sure you remember those things. Also, x equals, anybody remember? R cosine theta. And y is r sine theta. So we learned those yesterday, or we reviewed those yesterday. You should already knew them. But that's going to help us. So we're going to use these to convert equations. Alright, so let's start with rectangular to polar. We're going to have x, y equations, but we're going to convert them to our theta equations. Let's start with x squared plus y squared equals r squared. Sorry. 25. We need a number in there. X squared plus y squared equals 25. So what kind of shape is that? When you graph that, x squared plus y squared equals 25. A couple chapters ago. A circle, yeah. It's a circle with a center at 0, 0 and a radius of 5. So you could plot that. You could put a point, a center at 0, 0, count out a radius of 5 and draw a circle. We're going to convert it to a polar equation though. So what we need to do is think about the things that we know. And we need to say, well, x squared plus y squared is the same thing as r squared. So this is r squared. So I've got r squared equals 25, which means that r equals what? 5. That's your polar equation. R equals 5. So if I said in the polar coordinate plane, graph r equals 5, then you're just graphing a circle with a radius of 5. So if we graphed it, it would look like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Center at the 0, 0 at the origin. Circle. Center 0, 0. Radius 5. Pretty simple. Alright, next one. So that's a circle. What if I just wanted to graph y equals x? In the rectangular coordinate plane, y equals x. What's that? What does it look like when you graph y equals x? It's not a circle. It's a line. Just a line with a slope of 1, right? But to convert it to polar, here's what we're going to do. Y is r sine theta. So I'm going to put r sine theta over here. And x is r cosine theta. So saying y equals x is exactly the same thing as saying r sine theta equals r cosine theta, right? If I divided the r off of both sides, sine theta equals cosine theta. So we need to solve for theta, and you have to actually think. Where does sine theta equal cosine theta? What angle has a sine and cosine that are the same? Pi over 4. Pi over 4, 45 degrees, has a sine and a cosine that are the same. So your polar equation is just theta equals pi over 4. If you see a polar equation that's just a theta equals, then you know you're just going to plot every point along the angle pi over 4. So if I were to graph that, every point along the angle pi over 4 is the same thing as the line y equals x. Isn't that the line y equals x? Y-intercept of 0, slope of 1. Alright, let's do another one. X equals 3. When you graph that, what does it look like? X equals 3. It's a straight vertical line through 3. So how would we put that in polar form? Alright, x we know is r cosine theta. So now I just have to say r cosine theta equals 3. So I need to get either r by itself or theta by itself. Usually we get r. This is r times cosine theta. So how can I get rid of the cosine theta? Divide both sides by cosine theta. So r equals 3 over cosine theta. And you can write it like that, but most often you're going to see that, what's the reciprocal of cosine? 1 over cosine is the same thing as secant. So that's the same thing as 3 secant theta. R equals 3 secant theta would be a vertical line through 3. So if you were to graph it, it's just 1, 2, 3. That line right there. So converting from rectangular to polar just takes a lot of using the equations, using the formulas that we know, and then converting it to r equals or theta equals, usually r equals. Okay? Polar to rectangular is a little tougher. Polar to rectangular. So in polar form, we have r and theta. So if I said r equals 4 cosine theta, and I wanted you to graph that, I automatically know that's a circle, that's a line, right? But I don't automatically know what that looks like. After some practice, you will automatically know what that looks like. But right now, we just learned this. I'm not sure what 4 cosine theta is going to look like. So when we want to convert it to rectangular, we want to convert it to x's and y's. Here's a little trick. If I've just got r equals, make sure you write this down, multiply both sides by r. So if I multiply r by r, what do I get? R squared. And then if I do 4 cosine theta times r, I'm just going to have 4r cosine theta, right? I put the r out in front of the cosine theta instead of after. And the reason that we do that is so that we've got stuff that looks like what we have in our conversions. R squared, I know, is x squared plus y squared. So I'm going to change that to x squared plus y squared. And r cosine theta is what? It's x. So if r cosine theta is x, then we have x squared plus y squared equals 4x. It's kind of crooked, but x squared plus y squared equals 4x. And we're not done. What we need to do is recognize, okay, that's going to be a circle. but we need to group like terms. So I need to subtract 4x and put it with the x squared. And then I have plus y squared equals 0. And then we have to use our completing the square, which some of us are good at and some of us are not, but we've got to keep practicing. You have to be able to do that. So we're going to complete the square to make this a pretty perfect square. What do we add right here? I half this number, so I get 2, and square it. 2 squared is 4. I'm going to add 4. And in order to keep it balanced, I have to add 4 to the other side. So once again, the reason we did that was so that this factors to x minus 2 all squared. And then I have plus y squared. I don't have to complete the square on that one because it doesn't have that middle term. If it did, you would want to do it for this one too, but this one we don't have to worry about. And then equals 4. There's your equation. It's a circle. Where's the center? HK would be 2, 0. So your center is at 2, 0. And your radius is the square root of that, so 2. So we're going to draw a circle with the center at 2, 0 and a radius of 2. So when we first looked at 4 cosine theta, we didn't know that was a circle with a radius of 2. But now you know that because we did the conversion. Okay? Alright, another one. This one will be simpler. R equals 7. Look back to when we converted rectangular to polar. When we ended up with just r equals a number, it was just a circle with a center at the origin and a radius of that number, right? So if that happened to r equals 5, what do you think r equals 7 is going to be? Yeah, a circle with a radius of 7. So we know this is going to be a circle with a radius of 7. And how can we get the rectangular equation for that? Yeah, exactly. We're going to square both sides. Square both sides this time so that I have r squared equals 49. And then I can turn my r squared into what? X squared plus y squared equals 49. Isn't that the equation of a circle with the center at 0, 0 and a radius of 7? Yup. So if we were to draw that, that would be pretty easy to draw. 1, 2, 3, 4, 5, 6, 7. There we go. Alright, let's do one more. This time it's a theta. Theta equals pi over 3. So look back when we did rectangular to polar and we ended up with theta equals pi over 4. We were plotting every point along the angle pi over 4. So we ended up with that line. So if I've got theta equals pi over 3, I'm just going to be plotting every point along the angle pi over 3. It's just going to be a line with a different slope, right? So we need to figure out what the slope is in rectangular. So here's your trick. Here's what we can do when we've got the theta. Look at this. Tangent theta equals y over x. So I'm going to tangent both sides. If I tangent both sides, I can say tangent theta equals tangent pi over 3. And tangent theta is y over x. So now I can say y over x equals. And then tangent pi over 3 is something we ought to know. I know it's been a long time, but we should remember that. Here, let's figure it out. If I have my unit circle, pi over 3 is over here, right? So what are the coordinates right here? 1/2 and root 3 over 2. And tangent is supposed to be y over x, so if I did the square root of 3 over 2 divided by 1/2 is the same thing as times 2 over 1. So the 2's cancel, the tangent would just be square root of 3. So the tangent of pi over 3 is the square root of 3, which is your slope, because you multiply both sides by x, you get y equals the square root of 3 times x. So it's a line that crosses through the origin with a slope of the square root of 3. In this case, it's easier if we graph it keeping the angle in mind. Just went, okay, it's about like that, right? This would be pi over 3. Or your slope is up root 3 over 1, up root 3 over 1, either way. Got it? So that's it for our notes. That is your whole set of notes right there. Now you need to work on your homework. It's in the book. You have the whole rest of class to work on it and ask questions and help each other, and we can put them on the board, whatever y'all want. Okay? All right.